Okay, so today we're going to talk about how to figure out how old rocks are. Yesterday we looked at the rock cycle. Today we're going to be looking at using the rock cycle to predict how old things are. Now I'm going to first start off with showing you guys some pictures. Okay, so here's a bunch of pictures of some females. There we go. Look at them all. Look at all of these people. Now, unlike rocks, how could you tell how old all of these people are? Could you put them in order of youngest to oldest? Would some be easier than others? Probably. Like, for example, I'm pretty sure this person isn't as old as this person. But if you stack those two people together, and maybe these three people together, it might be a little confusing who goes where. Same thing for these guys. Maybe not. So these are also all separated by age 10 years. So it goes 20, 30, 40, 50, 60, 70, 80. And again, this and this guy are probably different ages. But if we put these three together, these look like the same guy. No, they're different guys. This is, I will find you. I will stalk you in Starbucks. Okay. Anyway, so the point is, even with humans, just by looking at things, looking at humans, it's kind of hard to exactly know. You have an idea, but it's kind of hard to exactly know. Okay. So what we're going to look at today is something called relative dating. That's which layers are the oldest and which layers are the youngest. Now, we will use, for relative dating, you have to use rocks that are found in layers or or in a stratigraphic sequence or a strata. And I talked yesterday about what stratas are. Stratas are, here we go. So stratas are the layers that sedimentary rock form. Okay? All right. So that's what they are. And remember, old rocks are lower because new rocks have formed on top. And that works except if there's an intrusion or slippage. So magma can come blasting up through some of these layers, and magma usually is really young, or the plates can start to get pulled underneath, and that makes things a little bit confusing. Okay, so we talked also yesterday about, where are we here? We talked yesterday also about the rock cycle. So most rock gets its start with lava. So lava, magma, hot rock works its way to the surface of the earth and spreads. And that rock is weathered by wind and pushed far away, like a dust almost, or rain takes it. But wherever that stuff goes, it forms sediments. And the sediments start to form layers. Like if you get enough layer, you get enough layer, you get enough layer, it compresses itself into a type of rock called sedimentary rock. And as sedimentary rock builds up, the pressure and heat from that can turn it into metamorphic rock. And as that layer slowly gets pulled back down to the core, it gets melted and blasted back up to the surface. Okay. Now, why is this important? Well, we can use the different layers in sedimentary rock to figure out a rough estimate of how old fossils are. Now, fossils this is an index fossils, are fossils that only exist in certain strata. So you might find like a Tyrannosaurus Rex, whatever. It's only going to be in a certain type of rock. So if you figure out how old that rock is, wherever you find that Tyrannosaurus Rex skull, that rock is always the same age. Now, it's not part of our curriculum, but it's really important in order to find a fossil, and we're going to get back to the rock cycle in a second. In order to find a fossil, everything has to go right with something that has died. not only does it have to basically die and not get ripped apart by scavengers back in the day, or find its way out into the sun and get weathered away to dust, it basically, as soon as the dinosaur dies, it has to get covered up by sediment. So that's why most of the time we find dinosaur fossils in riverbeds, ancient riverbeds, or by the ocean, because that animal, as it got sick, went someplace where there was water, it died, and a flood maybe covered it up with mud. Or it went out into the ocean, died, and sunk to the bottom and got covered up by the seafloor. So if an animal dies in the middle of a forest, it's very tough for it to go through the fossilization process, almost impossible. Now, then, on top of that, it has to be crushed by different layers of sediment and turn that once organic tissue into a rock. Because fossils are rocks. They're no longer anything living. All of the living stuff inside it is now a rock. Okay? So, just to give you an idea, these are different layers, and let's just label them 1, 2, 3. So, layer 1 is older than layer 3. Now, if we find a fossil in layer 2, and we've tested that around the world a whole bunch of times, and it's always in this type of rock, and maybe we're like, okay, this layer of rock takes, 2 million years to form. This layer of rock takes 3 million years to form. Then we have a rough estimate that everything that we find within this layer, other dinosaur fossils, other rocks, are about 5 million years old. That's what relative dating is. It's a guess. Now, there's some problems with it. There's good things about it, but there's also some problems with it. The big problem with kind of figuring out how old rocks are that way by guesstimating is that you could be wrong about how long the rock takes to form. During great floods, sedimentary rock formed a lot faster. Also, the layers could tilt. And then you're going to be really wrong. Or you could have a magma intrusion. Okay, not so good. So that's one of the big problems of relative time. So if I went back to this diagram, what would happen if instead of it being all nice like this, different layers of rock, you're like, oh, everything's all nice and horizontal. What if we had a magma intrusion, right? Now, I don't know if I can paint this in. Is it going to let me? Okay, come on, guys, let's... Okay, it's not going to let me. Fill color. Okay, well, that was a big fail. Okay, maybe we can go... We're going to go crayon. Aha! There we go. So this is the magma intrusion. So if we have a magma intrusion, we actually don't know how old the magma is. The magma is really new compared. It could have just blasted up in a week, because that's what happens in Kona with lava, one of the Hawaiian islands. You can have random lava just shows up the next day from way deep underground. Now, the other problem that could occur is, I'm just going to shorten these lines, okay, is you could have slippage or you could have tilting of the different strata. So maybe it's nice and straight over there, and then all of a sudden you have the plate tectonics moving it back down like this. And it gets way more complicated. You have different layers that start to fragment. So this layer here, if we follow it back up, is actually maybe the youngest. But if we continue the strata over, it's way deeper. So there's some problems with using relative time in geology. Two of them, again, one more time review: intrusions and the slippage or plate tectonic rock cycle, bringing that rock back down deep underground. Okay. So the last thing I'm going to leave you guys with are the three different types of rock. One is sedimentary rock. This rock is formed layer on layer on layer. It's like if you sprinkle dust on the ground and then over millions of years, every day you're sprinkling more dust, that dust will eventually form and get heavier and heavier and turn into a type of rock. Sedimentary rock is usually not very strong, and it's not formed under pressure, like great pressure. It's formed basically on the surface of the earth. And then what happens is over time, another layer will form on that, push that layer down, and that layer gets stronger. Another layer will form, push that layer down, and it gets stronger. So that's sedimentary rock. We have a lot of that in Alberta. Shale is a really cool type of sedimentary rock. Okay. Igneous rock. Igneous rock is not really around. Like, we have ancient igneous rock from old volcanoes in Canada, but we don't have a lot of it in Alberta. I have a really cool piece of lava rock on my desk I was going to show you guys that I brought back from Hawaii. Igneous rock is really young. It's formed from magma, and it's blasted up to the top of the... it's blasted up. So you can think of the different types of volcanic rock that's really porous, which is really light and airy. And then obsidian. Obsidian is another type of igneous rock. Okay. The last type of rock is metamorphic rock. Metamorphic rock is igneous rock that has become sedimentary rock that is now moving its way deep under the earth and is getting crushed into another form of rock. And that has very, very interesting properties. Also, you could have two tectonic plates that smush together and form into a mountain, and that's where granite comes from. So granite was a sedimentary rock that got smushed together from tectonic plates bumping into each other, and then instead of going down, the mountains go up. And that's why the mountains have so much granite and very heavy, dense rock inside it. So I'm going to have a video that goes with this that's going to show you the three different types of rocks. Okay, that's it for today. So there's going to be a quick second video, and then from that video, I'm going to have a Google form that you guys are going to do. We're going to start our assignment tomorrow that's going to be for hand-in. So the assignment today is just a quick recap using the video. I'm going to show you different types of rock. Okay?